Hi class, welcome to our first asynchronous lecture in Business 306 Stats. The asynchronous lectures are going to follow the course manual for the most part, and we'll be going through them piece by piece. For Unit I, we'll break it up into two different lectures, and so this one is going to look at pages 1 to 5. Actually, I'll talk a little bit about 6 because it'll mostly be for homework, and we'll take that up in the synchronous section. And then on the next class, we're going to look at 7, 8, and 9. So let's dive in here to Unit I, which is the introduction. Actually, before I do that, I just want to show you a little diagram that I'm going to be coming back to frequently in this course. And it really shows you how this course is set up. So what we've got is 9 different units here. The first one is the intro unit. That's at the very bottom down here. Maybe I should just come up with a different color here. Okay, so right in here, we've got Unit I. That's the intro, which takes us into this whole mess. And then we've got some building blocks here. And so the first one here is Descriptive Stats, which we'll be jumping into right away. And it's got 2 units, units G and C. G is for graphs and tables, and C is for measures of centrality and dispersion, how we describe numbers. And then we're going to jump over to another branch of mathematics called probability, so that's unit P. Those two are going to go together, though, to bring us to probability distributions. And we'll be looking at 2 probability distributions, units B and N. And then finally, we'll be going up to inferential statistics, so they all go together here, and we take a look at estimation and hypothesis testing. We will, at the very end, have a bit of a branch off, which is kind of an intro to the next stats course. And if this is your only stats course, it gives you a little bit of taking a look at some bivariate analysis, and we'll talk about that when we get there. Hey, one thing I want you to note here is that the first couple of units here, maybe the first 3, so beyond the introduction, so G, C, and P, the ones in this bottom layer here, are ones that you might have taken some of these concepts in high school, and you might look at this and say, oh, I've taken all this before. All I'd ask is that you kind of hold tight on that one, and this course does ramp up as we go through it. So with that, let's jump into Unit I, which is the Introduction to Statistics. It's a good idea to read those introductory paragraphs here. I'm not going to read through them. You can do that on your own. But down at the bottom, it does talk about the subtopics that we'll be looking at. We're going to define statistics, look at some problems faced by statistics, what primary and secondary data are, and then deceptive visual presentation of data. And then we're going to talk about some statistical articles, and you're going to look at those and say, well, are they good or are they not good? So with that, let's take a look at some definitions here. And the definition of statistics is the body of techniques or methodology that is being developed for the collection, presentation, and analysis of quantitative data and for the use of such data. Yeesh. But an important word I want you to really note there is the word quantitative. Quantitative means numerical. So I might say to you, hey, how are you feeling today? And if you answer, I'm feeling really good, or I'm kind of stressed out about today, or something like that, then that is a qualitative answer. A quantitative answer might be where I say, on a 10-point scale, how stressed are you? And you say, well, I'm feeling about a 7 today, so I'm pretty stressed. Then that's quantitative, it's numerical, and this particular course is dealing with quantitative measures. Descriptive stats involves the presentation of data in easily understood forms. So if I was to give you a mass of numbers, let's say it's 10,000 numbers on an Excel spreadsheet, which is the lifespan of some light bulb. Now, I don't know what light bulb we're talking about here. If I was just to give you those numbers, you wouldn't really have a good idea of what those numbers are, especially when they're in a big, long list of 10,000. And especially if they're not sorted in any way. So what would you do to make sense of them? Well, you could sort them. That would be a good thing. So you got the lowest and you got the highest and so on like that. But even then, it's kind of hard to get your mind around 10,000 numbers in a list. So what we do is we put them into classes or groups or categories. So you might say, let's put them in classes of hundreds of hours of lifespan. And then we might draw a graph of that. Later we'll call that a histogram. Or we might look at coming up with some singular numbers which describe the data. So an obvious question would be, well, what's the average length? And there we're talking about the arithmetic mean. We'll get into that in Unit C. Or the median, or the mode, and we'll define each of those. Or what's the range of the numbers? I mean, do they range from 10 hours up to 10,000 hours? Or are they more tightly compact in, say, the 5 to 6,000 hour range? So that's the range. Or we'll come up with a better measure, which is the standard deviation. So that's descriptive stats. There's lots of other things like percentages and so on like that. And we're going to be looking at some of the main ones, so in units C and G. Now, I've got a class exercise down here. And the reason I got it at the very bottom is I've got my solutions typed underneath this. So I want you to give some thought to this question here then before we go through the answers here. If this were in class, I would toss the question out to you, and then we would take a look at the graphs, the charts, and we would then talk about it and make a list on the whiteboard. But we're not going to do that here, obviously. So consider the charts on the next 2 pages showing the population data for red deer in 3 years, 86, 2008, and 2016. What are the advantages and the disadvantages, really, of each way that the data are represented? And by the way, there's no right answer. This is really a personal preference thing. We'll see in some cases then that it might be better to represent it in a certain way. But let's take a look at them. So I'm going to rush through the next page here. We'll get back to it. And look here at the 2016 data. So a couple things I want to point out, of course, is that you got a lot of numbers there. You've got a lot of classes. The classes are fairly small in size. So 0 to 4 years, that's 5 years. 5 to 19 years, that's another 5 years. They're all 5 years, actually, in terms of class width. And there's a lot of classes then. You've got the exact numbers of males and females and the percentages. And you've also got the unknowns at the bottom and the rather not says. So you got a lot of information there. 1986, by the way, 2016 was the last data census that we had here. That's why that's 2016 data. The rest are estimates beyond, after that. 1986, this is actually how they represented the data, and so I just kept it there in this book. I thought that it was a good representation here. And it's got a visual, which they've got in there as well, so that's kind of nice. But take a look at the age classes. They're kind of goofy. 0 to 4, and then 5 to 14, 15 to 19, and then you've got a little bit later, you've got class widths of about 20, right? 25 to 44, and 45 to 64. What's going on there? Well, we'll get back to that in a moment. And then the last one here, oops, that's not what I wanted to do, is the 2008 data. And this one's a little different. It's got the same classes, actually, as in 2016. And it's got a nice visual, but you don't have the exact counts or frequencies, the actual number of people. But it's actually really good in terms of comparing the males and the females because the bars are side by side. So take a look at those. Of course, you can pause this, and you can, before we go back here, take a look at each one, see which one you like. And so I've summarized some of the points down here. So in 2016, the pros then, I'm looking at this part right here, okay, is that we've got a lot of classes and they're all of equal width. Statisticians actually like that. It's better for calculations. We've got exact counts, or later we'll call them frequencies, and percentages, as well as some other things like the non-respondents and the people who refuse not to say. The cons is that there's no visual representation, which is something that the others had. 1986, you have exact numbers, you've got visual representation, and the age classes, actually I want to get back to that one here, but the age classes represent the time in life, so I'm going to go back and show you that. The cons is that you've got fewer age classes and they're not equal, and it's a little harder to compare the males and the females than it is in 2008 where the bars were together. In 2008, it's easy to visually compare the males and the females, and you got a lot of classes and class widths, just like in 2016, but you don't have the exact counts. Okay, so let's take a look again at, well, those last two in particular. So this one in 2008, it's easy to compare the males and the females, but you don't have the exact numbers. Here you've got the exact numbers. You've got a visual. It's a little hard to compare the males and the females, except that you've got the exact numbers. But what I want to focus in on here is what the Frodo is going on here. Why do you got age classes like that? Well, it represents the time of life that a person is in. So 0 to 4, we're talking about preschoolers. 5 to 14, you're talking about school-age kids. 15 to 19, you're talking about teenagers, and then you've got young adults, then you've got young families, establishing families, then you've got established families, or people who are at the height of their profession, and then you've got seniors. So you can see that there's an advantage to that. Okay, I want to get back here to this question here, and it says, give me some other examples of descriptive stats. And so you might want to pause this and give it some thought. But here's some that I came up with. Sports scores. So if you take a look at a newspaper, of course, the sports page is a big one there. A stock page, weather stats, disease rates, mosquito bite rates, ages, and all sorts of other descriptive things. But if you're in a business, then you've got things like accounting data, the finance department, the marketing department, they're interested in the demographics of customers. The HR department looking at sick days, vacation days, production rates, and things like that. I'm just going to close the door here. Somebody walked in. Sorry about that. We've got a busy household right now. And then, of course, things like averages, ranges, standard deviations, numbers that we're going to learn about in Unit C are the things that we use to describe these kind of things. Inferential statistics. So remember, we've been talking about descriptive statistics up here. Now we're going to take a look at inferential statistics, which actually builds on descriptive statistics. It involves drawing conclusions about the unknown characteristic of certain phenomena on the basis of only limited or imperfect information. What that really means is taking a sample, and then based on that sample, making informed statements about everybody or the whole population, whatever that is. Like a poll, like an election poll, right? So you sample 1,000 people, and then you come up with an estimate as to who's going to win the election. Here's some examples here. Things like population risk, increase. What is the population going to be next year? Stock risks, if you're in finance, marketing surveys, manufacturing defects, the rate of defects if you're in production, political polls, opinion polls. There's lots of examples of inferential statistics. Okay. Page I-5, problems faced by statistics. And we're going to take a look here then at, first of all, a statement that there are lies, there's damned lies, and then there's statistics in order of severity. And other people tend to say, well, you can make stats say anything that you want. So there's a lot of people who have a lot of suspicions about statistics and don't think much of them. Our hope is that we want to get you more comfortable with statistics, but also to become critical consumers of statistics. And we'll look at that at the end of this unit here. There's three problems that statisticians are faced with. It's the collection of the data, and then just showing where we're going here, the analysis and interpretation of the data, which actually is the guts of this course, so there's not more than a couple of lines here, and then the presentation of the data. So we'll talk a little bit about that actually in our synchronous session. But let's go back here then, and we want to make a distinction here between primary data and secondary data. Now, primary data are data which are collected by yourself or others for your purpose. So it's data for you. Whereas secondary data are data that are collected for some other purpose. So for instance, if you have a marketing research team in your company, then they're probably collecting primary data for you, your company, so you can figure out when to put out a particular product or where to set up a new store location or something like that. Secondary data are data like they would be population figures that Stats Canada puts out. And so again, you can take a look at, well, where should we put our store? So that's the difference between primary and secondary data here. In terms of primary data then, the important thing is that it's about data which are collected by yourself here, or for you, not necessarily by yourself. I'm just going to put this down here. I'm going to write this part out here. So that could be things like, marketing research. In your particular company, and so on like that. It could be things like accounting information. So accountants, of course, are always collecting data, that sort of thing. It could be the HR rates. So these are all things actually that we saw before, and so on. You might be interested in just your own poll if you're interested in how people feel about something. So you could go and ask your friends, hey, I want to ask you this question and tell me what's your thoughts on this. That's collecting primary data. But anytime the data is being collected by you for yourself, or you could hire, say, a marketing research company to come in and do a survey for you, then that's something that is primary data. We did one for the Alberta Winter Games, and it was quite a big project, but they hired a group of college instructors, and we worked with actually 4 different classes to come up with surveys for the volunteers and for the participants and for the guests, and it was really an interesting thing there. We did another one for Westerner Park, and that was in a previous year, and so there's lots of different things that we've been doing there. If you go on to 307, you'll be engaged in primary research there, where you'll be working with a company. Let's say it's or an organization. Let's say it's a restaurant and you want to do a customer satisfaction survey. Then that's collecting primary data for them. Secondary data is things like things put out by, say, Stats Can. And so that might be the employment statistics. And it could be things like population numbers and so on like that. And so you can use that then in some sort of way, but it wasn't collected for you. It was just collected in general, or it could be collected for somebody else. Who collects it? Well, probably the best thing to do is, let me take you to a couple of sites here. I want to go into a list of polling organizations, and in particular, here's Canada. And so these are some numbers or some names that I'd like you to know. I don't want you to know necessarily anything about them, just actually the names of them. So Abacus and Ecos Research, Environics, Forum, Ipsos Reid, and Leger Marketing. So those are the most common ones that we have in Canada. If you take a look at the United States, there's some that you may recognize. And so Gallup polls. So we'll be talking about, I'll show you an example, of a Gallup poll, and so on. Nielsen ratings are interesting. What Nielsen ratings are is for rating TV shows. So that's how they figure out whether a TV show should continue or not. It used to be that they would send you a little booklet, and you would fill out what you watch. But now you can actually just get a little machine, and they can actually attach it to your TV, and then you can record it. Or now I think actually you just simply give them permission through your cable company, and they can record what you're watching when. Pew Research Center is one which I've seen a lot of things with. And so those are some of the ones with the United States. If we go back to Canadian stuff and taking a look at election trackers, here's the poll tracker that CBC puts out. And so that's telling you poll averages. So this is based on a whole bunch of different types of polls. And it's saying that if an election was to be run today, then the Liberals are at 36%, and their probability of winning down here is they would get anywhere from 119 to 212 seats. And they would need, that's just short of a majority, I think, by about one seat, and so on. But that's based, there's a bunch of regional stuff and so on. But here's the individual polls that they're basing it on. So again, there's the names of ones that you've seen before. All right. Top marketing research companies in Canada. And I don't want you to know these names here, but these are not ones dealing with politics. These are ones that are dealing with bigger types of particularly corporate surveys and so on like that. So lead generators, fresh squeezed ideas, a whole bunch of these. And to tell you the truth, I don't know most of these. If you wanted to find out in Alberta, actually in Red Deer, where would you go? Actually, Red Deer College does a fair amount in terms of just our area here. So that's why Red Deer College is up here first. But there's Advantis and so on like that. Scully Research down here. Bruce Scully actually has taught this course before, and so he's a researcher in the area. And then there's Stats Can. And so Statistics Canada, which is one of the most respected statistics organizations in the world, actually does, I think the stat I read was that they collect more data than all the other private organizations, as well as just what you collect in your company, all put together. This is what they do for a living, and so there is tons and tons and tons of Stats Canada stuff there. All right, let's go back here. So you can just scratch down a couple of notes in terms of what you just saw there. The main thing is Stats Can, and Stats Can is probably greater than 50% of all the data which is collected, and then some of these other ones which I just showed you. That's about where we're going to end it today, but I would like to leave you with a little bit of homework here, and that is when we meet together next week, then what we're going to talk about here then is this one here. What are the advantages and the disadvantages of collecting primary data versus secondary data? So I'd like you to make a list, and we'll actually do that as a class exercise when we get into our synchronous session. And then what I'm going to do is I'm going to go through just a bit of a PowerPoint that's talking about the presentation of the data here. And you can actually scratch down some notes here on that as we go through that. So that's where I'm going to leave it today. We'll have another one later on the last 3 pages. But we're going to leave it there today, and I will see you